Hi, so this is the demo of my final visualization project. So we had to make a dashboard about a dataset. So the dataset I had chosen is the Australian credit approval dataset. So basically it has rows and each row has a 14 variables, and these 14 variables have and the target variable. The target variable is whether the row has been approved for a credit card or not. So as you can see, I have made a dashboard over here, and you can see the entire dashboard without scrolling. And so basically it reduces the load on the user's memory, and user does not have to memorize many things. Then you can see a parallel coordinate in the top, and I've made that so that you can see all the 14 variables together, and each of the line represents an entry, and you can change the order of the axis, but the current order is based on the correlation of each of the attribute against the target variable. So basically, you can see prior default. So it has a correlation of 0.72, which is a very high correlation. So that is the first axis. And based so similarly, I have ordered the axis in such a way that all the axes are in the highest correlation to lowest correlation. So basically, you can see that when I select education over here, you can see that most of the higher educated people are approved for a credit card. Then similarly, most of the lower, less educated people are rejected for a credit card. So, so based on such observations from the visualization like these, you can, I made some inferences. So basically, the most important thing is the good track record of a prior credit. So that is the prior default. Then a steady job is very important, and then after that a well educated person is more likely to be approved for a credit card. Then you can see that this is the dashboard of the total data. So I have made, this is a scatter plot of the just the PCA of the two vectors of the entire data set of the first two vectors, and you can select the only the ones you need, only the ones you want to see. And you can see accepted 40 and rejected only one. Then the credit history. So the people with the longer credit history, the more people are accepted. Then again, like in education, more number of people are approved for a credit card for with higher education. Again, prior defaults. Then the age also plays a part, but it's not really that significant. So that's why it's the last one. This is the correlation plot, and this is the scale I've made. So the color scheme is made in such a way that even the colorblind can see, and you can see the example over here in this website. So I can select all the different colors combinations, and people with different color blindness will be able to see it like this. And so this color scheme is pleasing to the eye, and also like accessible to everybody. And the rest of the fields are just the fields I had from the second assignment. And this is like the intrinsic dimensionality of the vectors. Then this is the PCA plot. This is the multi-dimensional scaling, but it takes us some time, so I won't display it. And this is the PCA first three dimension in the scatter plot matrix. Then you can see that brushing and linking is active here. Then this is the PCA three-dimensional. So basically, the first three dimensions of the PCA principal component analysis is done, and the first three vectors are taken and plotted. And you can see interact with the plot and see that there is a difference between the data. So again, the dashboard, you can select multiple axes, and this will kind of help you to understand the data more. And based on that understanding, people are able to set the interest rates, credit limit, and even approval or rejection of the credit card. So okay, so that's my project. I hope you enjoyed it. Hope you liked it. If you have any questions, let me know. Um, Thank you. Thank you for your time.